All right. In this amp, this gentleman wanted. This is an SB220, and normally these amplifiers, guys will use a foot switch, or if you've got a Yaesu or something like that, it has an automatic output on it already. But what we did was he wanted the amp repaired, so we did that, and what we've done is back here you'll see this whole conglomerate. This is our sideband and 12-volt keying circuit. Now what happens is we've added this independent 12-volt supply. This supply does not electronically touch the rest of this amp except for the input over here for the AC. After that, 12 volts comes out, comes over here to our standby switch, which gives us our AM upper sideband, or it gives us our AM and sideband, in the middle standby, and all the wiring for it. Look, guys, when you work on a 220, when you're done, tie everything up. This is the worst amp in history for arcing off of stuff. And I see something right now that I'm going to have to correct. That little guy right there, we're going to have to tie that off and lengthen it or something. Right next to the high voltage choke. That's an arcing problem. That's 110 volts right next to 6. I don't want to see that arc, so we're going to fix that too. But what happens is, like a normal keying circuit, your RF comes in. This transistor is pretty hardy. It'll take 100 watts. So this transistor takes the 12 volts that's floated from the rest of this amp, and it only controls this 12-volt relay. Now, when this relay engages, it closes 2 clamps, just like you'd be stepping on your foot pedal, and it engages the manual relay from the amplifier automatically. Now, the cool thing that happens with that is, say he's got an even bigger box he wants to drive with this. We left his output keying circuit, what was his input keying circuit from the pedal or whatever, now it's an output. So when this amplifier keys automatically, he can use that RCA jack to pump into another amplifier, and his chain will all key automatically. There were a few issues with this. This thing was hanging. We got it settled down in there. All these wires were just not tied up right. We had some cap issues on the sockets. He came in with one regular Z and another graphite, and I happen to have another graphite here, so that's what we put in for him to test it, and he said just leave it in there, so he's going to get the 2. But now the way it works is, in the middle of standby, to the left is AM, to the right is sideband. Real simple to operate. There's shavings from where I drilled everything out. But there it is. It's all done. There's our keying circuit. Let's see if we can make some power and see what happens next. So far, everything looks good, but we'll see when we get ready to fire it up. So now he has automatic key. All done. 7 trees. All right, we're going to try this again. Normally we don't do a video on every single piece that comes through here, obviously. But this one, for you guys that like these amps, these SB220s and 221s, a couple things to look for. This one came in missing a tube. He had a tube. I mean, he had both tubes in it, but one was a straight Z and one was a graphite. I think that's a no-no. But we were missing a parasitic choke. High voltage inrush right here was popped. But it said it had high voltage on the front. Filaments were lighting up. I said, okay. He said, I also want automatic key. So he had a couple issues. Like you'll see in another video, the rail for converting it from 110 to 220 was hanging in there. We secured that. And we put an automatic keying circuit in it, which we have not put the switches out the front yet. He will have 2 mini toggle switches in the front when I'm done. One's going to be for sideband, one's going to be for AM. But what happened was, when we went to key it down to test it the first time, of course our shield's on over here, and we had a lightning bolt showing here. And this is why. First things first, you guys got to remember, when it says Heathkit, that means somebody like you or me built this thing. It wasn't built by Heathkit. It was thrown in a box. Well, carefully and lovingly put in a box by the people at Heathkit, and it was up to us guys to assemble it. This board has been modified over the years, but there's a couple of things that I see that bother me. Every one of these boards that I've rebuilt, as you'll see in the board that we replaced it. First, this is why we replaced the board. This kind of stuff right here. See that, how burnt that is? And a lot of that is flux. But that whole landing will lift off the board. And because somebody decided to make parts in a high voltage section where, here, there are times when you need to make up wattage is fine, or make up ohms is fine, as long as you have the room that the heat that whatever it is you're concocting is going to be able to dissipate. In other words, the original deal on here, I mean, shit, it's only 0.82 ohms to 2 watts. Okay? That's what it's supposed to look like. This is some conglomerate somebody put in here. Both of these resistors made a whole lot of heat. Another thing is this. Let's go down in here. That is these guys. I'm thinking right in there. Okay? Right there. Well, one of them they changed to this conglomerate. That little black guy right next to it is what's supposed to be in there. Here's the problem. When you make these parts like this and make them bigger, they make more heat. There's already enough heat in that section then there should have been, you know, it's an old school amplifier. In the interim, what got the sample is not so much that they did some poor repair work, and I'm going to show you something that should be done on all these. I don't know if it's in the book or not, but I'm going to show you because it's the way I rebuild them when I rebuild them. If, like I said, had the landings on this one, I've been already coming off the board, we'd rebuild this one, but that's not a hope. But in the interim, where our lightning show came from was this. Now, anybody who's ever taken apart a 220 knows that once you get it out of this sleeve, okay, and this one had the danger high voltage ripped off of it. You get it out of the sleeve. Now, I want you to look right down in here. That's where all our heat was getting made. Okay. Part of it, I think, was poor solder work. As you can see here, is what once was the center tap, and it was extended. Now, I did extend it just because they had to cut it off and put this bull on there. But we actually shrink wrapped it and then electrical taped on top of it and still used the cloth original wire. Okay, they had some wannabe high voltage shit in there. No good. 4 out of the 8 caps are popped. So, both of these now gone. He's now gone. Okay, now here is what your high voltage should look like on a 220 when it is healthy. We have our fluke here that I bought from what I thought was a buddy of mine and ended up spending more at Fluke getting it fixed than I did actually buying it from him. But now we have a nicer meter. High voltage probe was good. So now we're going to check this guy, right? When you turn these on, I always suggest that you put them in the CW tune position first, and then, or over here in the CW tune, and then turn it on, which is what we're going to do now. Now I have a clip on my high voltage lead, so I don't have to get near none of this. We're on DC volts, we're on CW tune, and we're going to turn it on. Now when you turn it on, bam, lights should come on, and that meter should come up if this is set all the way over here, all the way to the right. But now let's go look at our voltmeter. And this is a 10-to-1 probe, which means that's 2,378 volts on CW tune. Where we had the problem was when we went to high. When we took it off of tune and went to SSB, it lost its mind. But now, as you can see, pop this, and when we pop this, you can watch the needle jump. Nice and neat like so. 2,963 volts. No arcing, no sparking. Now, here's an assembly tip, and I don't know how clean I get. You know, or here, an assembly tip for new stuff. This was built back at what God knows when, but if I can get in on it, it gets you some light. There. Now, you see that Zener diode? Now, you see the tab coming off of it on the bottom? That's just right off to the right. If you take and loosen this diode, loosen the stud, and take that ground tab, it was swung all the way around over here, right next to those blue wires. Guess what those blue wires are, folks? That's your high voltage. I think what got this amp to begin with was poor assembly, lack of attention. You don't put a ground tab less than 1/8 of an inch away from your high voltage landing. That was dumb. We repaired that. So now that we got all our voltages in check, and let's go back down to CW tune, and we're going to watch it drop. Now, the next thing on these is this particular amplifier will bleed itself down pretty quickly if it's been put together properly. Okay? Now, we did some cleanup work, but first, before we get to that, here's a high voltage board. I don't know if it's the original, but a high voltage board. Now, I don't know. I've seen them built just like this, only not with this conglomerated garbage on top. But here, I've seen them built like this with no filtering or balancing across the diodes. Everybody does that on the caps. See those big green resistors? That's balancing the load going across each set of caps. Well, the right way to do these diodes is also kind of just like that. You use a high meg resistor, a 1000 volt cap. I like to use 103s, but you put one across every diode. You see that, folks? That's what this rectifier board should look like. This thing is going to have nice, clean audio with no buzzing in it at all. When you put one together like this with no filtration across the DC, this is a big doubler, okay? I mean, this is a pretty good sized doubler. It's really rocking. You really want to keep that particular rail as clean as you possibly can. You'll notice every one of these diodes has got that high meg resistor with a cap going across each actual diode. That's going to keep it nice and neat. Now, and you'll notice on this one, there's the original resistors right there where this guy's got this freaking mess. So it was better, and the landings are coming loose. This board is just junk. We're going to put it back. It's garbage. Turn my zoom off. So there. On CW2, roughly 2300 volts, just short of 2400. When you take it to SSB, there should be no arcing, snapping, or silliness back here, and it should go clean up to 2900 volts. Now we have a healthy high voltage section. I know our keying circuit works because I've already tried it. We still have to add the switches and I believe a pad. We usually use like a 470 in line with the keying circuit on these big amps just to suppress. All that transistor wants to see is enough to tickle it and excite it, and it'll key everything. So, but when you guys are running 100, 200 watts PEP into these amps to drive them, sometimes those keying transistors don't like it. Even though I do use a metal case transistor, we still pad them, especially for these big amps. So the next story is going to be, we're going to flip this thing around. We're going to double check the keying on it, and we're just going to dump a regular radio into it at first and see what kind of power it makes. But here, just a word to the wise. When you see one of these Heathkits, if you buy one, inspect it thoroughly. This is what the inside of this section should look like. Absolutely, no questions. Somebody did a nice job when they built this particular board. I'm not even going to tell you what it cost me because it was freaking expensive. But all the rest of it, here, could I have rebuilt this board? Absolutely. But I would have more hard wires strung across the back to make all the circuits back to normal than it would have been worth. This board, all the landings are tight. Everything's only been soldered onto it once, other than what I've just done. This cat pack is actually out of a very low hours amp, and it was assembled properly, and we've double-checked it. And there he is. We're going to stand behind this piece now. The other thing is, he came in, and he had, in the sockets, 2 different styles of 3-500Z. Now here is your regular, this is like, I believe it's an EMAC, regular 3-500Z, and if you look at the inside, you see the cone. You see the fins, the grid, I don't know what you want to call that. And a lot of shrapnel inside this tube from what I can see. But in the other side, he had one of these, a graphite, okay? That will work. It will make power, but it's not good for the tubes. To test this unit, he did have another graphite tube that was bad. The filaments are bad. He's got an RF Parts 3-500ZG in here. It is what he brought in with it. We have a Taylor 3-500ZG, which guess what? They're made at the same place, same tube. So basically the bottom line is we have a pair of graphites in here now. You really shouldn't mix the regular cones with graphites. It's not a good idea. They draw different types of current. They act differently in the circuit. Their cues are a little bit different. You really want to keep these matched. If you're going to run but I call them paper cones. If you're going to run the regular Z's, run a pair of regular Z's. If you're going to run graphite, run a pair of graphite. Don't mix them up. So now let's put this thing in motion and see what happens. See you guys in a short. 7:30. All right, I told y'all this was going to be a nice amp. Okay, customer opted to keep the ZG tube that I was testing it with, so now he's got all his tubes in here. He's going to get it back intact. As you can see, we got everything fired up, running nice and neat. Now this is an automatic key right now. I have not put the switches on the front yet. They're still underneath, but we are keying it. This is one of our other little creations. This little Navajo, if you look on the back, you'll see those couple of knobs. Well, that's to control the 2879 board that we have inside it. This radio will dead key all the way down to 1 watt or all the way up to 20 watts and swing PEP 125 or RMS about 3540. So we're not driving this with nowhere near what it wants. However, it's making pretty damn good power for the minimal amount of drive that we're giving it. This amp really wants 100 watts, 125 watts of RMS to drive. And I gotta go all the way and grab my microphone. So here, this is what we're doing. We're hitting it with about 40 watts total PEP swing or total RMS swing. Amp on. Oh, we need to turn that up. We got it down like a 10 watt dead key. Let me turn that up. That is way too low. Let's see here. Get my finger out of the way. See, now I'm doing this right on the back of the Navajo. Let me get my finger out of the way. There we go. Now I'm doing this right on the back of the Navajo. Now you notice I just kept that key for a minute. Let's take it up to a 75 watt carrier. There we go. Now, 1,000 watt reading. Audio. That's a 75 watt carrier swinging 600 watts with just a little bit of drive. Something else about this amp. Somebody has taken and pulled the band switch out, which we have no problem with around here. We don't use a band switch. However, they did the right thing. They changed this to an input tuner. Now, when you do this, the cool thing is you can peak this amp out. And then if you don't have a carrier control like we do on this Realistic, all you got to do is once it's tuned for peak, if you want a lower carrier, is key it, don't modulate, bring this counterclockwise back to your carriers where you want it, and you're going to find out that your PEP swing is still going to be right where you tuned it. So that's a cool thing about we use this style of tuner in all our amps. This guy did it nice. He put it on where the band switch used to be. And if you look down in there, he used a really nice air variable tuner for it. There you go. Real nice air variable tuner. Now over here you can see the issue I was showing you earlier with this Zener diode. I don't know how close I want to get. This thing is on right now. But you can see that tab has been turned down counterclockwise away from the high voltage rail, which it was right next to. And that's what I'm talking about when you guys get a Heathkit. Before you even plug it in, if you know anything about the amp, you need to go all the way through the amp. Make sure all the screws are tight. Here, this guy, I'm not going to touch it, but you see this guy with the blue wire right here? Right now that's got, because all our meters work, 3,000 volts going to the top, all right? Now, this whole assembly, from where you see that nut and that blue wire, it goes through the ceramic isolator, which is literally bolted to the ground of the chassis. But this ceramic isolator goes through, allows the high voltage to go across our protectors to our choke and to our tubes. Okay, this bias diode's tab for the ground was right next to the freaking output rail. No good. Made an arc. Something else you should never do is splice these wires if you can avoid it. I had to because somebody cut it, but we soldered it, shrink wrapped it, then wrapped it in tape, and still used cloth wire on it. Now this is pretty much the way this amp should look when it's assembled and the side is off. Okay, as a matter of fact, this is exactly what it should look like. Every one I've ever owned for myself, I do the caps and the resistors across all those diodes. Okay, as well. Okay, as well as on the cat pack. And like I said, now all we're going to do is we're going to add our right, I think here. We're going to put our operate standby and AM sideband switch. And then this is a fully functional, independently keying. Oh, and by the way, all the meters work. Check this out. This is the coolest thing. Anybody who's ever had a 220 and all the meters works, they're blessed. But there's our high voltage, right? So we're on the high voltage setting. So if I go down here and I set it to CW2, and it should go to about 2,500 watts. Boom! 2,450. Perfect. This meter works as it should. Now, if I take this to the relative output, I've already got the sense. You got to set the sensitivity. And I've got it set a little hot, obviously. But there's that meter's working perfectly. Now let's go to grid current. Works perfectly. DC milliamps. Pulling 50 milliamps, 500 milliamps actually. According to that meter, 500 milliamps. It's a half an amp of 3,000 volts. So there it is, man. This 220 lives. But once again, a lot of times you guys get these things on the cheap, and you figure out why. He thought he had a couple small problems until we fired it up. I had to call him in and tell him his entire high voltage section, there's what's left of it, his old one, was just trashed. So we put a whole brand new one in here. And a nice one on top of it. Without the landings coming off the damn high voltage board, nothing arcing. Lamps and the meters are lit nice and neat. The tuning for 11 meters is perfect. The tubes don't cherry up. Fan runs. This is a keeper at this point. But when you buy these guys, inspect them. Look for loose screws. Look for shitty soldering. Look for, stuff not routed. You see something, when you see something that looks out of place, it probably is. Because the way this Heathkit was laid out, everything's pretty much got a path. And you'll notice in the other video when we laid out the keying circuit, we followed the path of all the Heathkit wires. So, when you add something to an amp like this, and here, this is what we did. This is how the keying circuit works in this particular amp. I'm going to tell you because the video's on, you'll see the video earlier. But you've already seen this, but I'm going to explain it. We add a 12-volt power supply, a small one, into the bottom of this amp. Where did my thing go? So we had a 5-volt power supply, or a 12-volt power supply to independently run one little 12-volt relay. We put a keying circuit on that relay. It clamps and fires our 110-volt relay. So that's how that works. But anyway, there it is. We're good to go. We're going to put lids on it, and we'll catch you guys later. 7-3s. All right, let's try this again. So now, when this amp came in, it was missing. It had a regular 3-500Z over here. This choke was missing. These safeties were blown. This is what feeds our high voltage into the safety, into the choke, to the tubes. This was all blown. This guy right here, this goes through this chassis, and this is where the high voltage feeds through. Now, if you look, you'll notice the ceramic inserts right here. These ceramic inserts meet in the middle of this metal and isolate this from the chassis. However, every screw on this thing was loose. It was arcing. Then we go over here, and I showed this earlier in another video, but we're going to show you again anyway. This diode right here, okay? If you look, you see that little ground tab on it right there. Let me just take this down. See the ground tab? Well, right over on the other side of that, you look up in there, that pad way up in here, right there, see that pad? If you go over here and look, that's your high voltage. They had this diode bolted down in a fashion where the ground tab for it was less than 1/8 of an inch away from the high voltage tab where it's feeding this over here. There were a lot of issues. So when we got ready to fire it, he still had high voltage here. So we went ahead and tested and went to fire the amp, and we had a fireworks show on this side of the cover. So we pulled the cover off, and I could tell somebody had been in there because there's only one screw in it. And we replaced his entire high voltage section. Not just the board, not just a cap or two. The entire assembly has been taken out. It's in that bag. There's foils coming off that board. There's parts rigged up on that board. This is the way Heathkit intended this board to be built. Actually, it's a little bit better because I don't think Heathkit instructed the guys to do this with a high ohm, high meg resistors and the caps across those diodes. I do it in my amps. It keeps everything nice and stable. So now, after we tested it, I put one of my graphites in here that kind of matches, and the amp is now functional. You've seen the functional video. So here it is. It's all done. Self-keying. No more keying switch. As a matter of fact, it will key something else automatically as well. All the meters work. He said, leave that tube in there. It's all working. Let's leave it alone. We've gone through every inch of this bad dog. This is a nice 220. And something else, guys, when you're working on these amps, you see these bottom rails? I had to take both of them off this amp and hammer them straight. These are not for picking this amp up after you take the cover off. Those are there to put screws in after you put the cover on. Okay? Do not grab this amp by these rails on the bottom. You're going to bend the dog cheese out of them, and then it's going to look poopy when you put the cover on. So, and if you get one of those rails are bent, take them out and straighten them. This side was really bad. And this is where our power supply is for our automatic keying. So, when it comes to a 220, guys, it ain't a regular amp. It's a simple amp to work on once you understand it. To a guy that's not used to playing with triodes or big glass, it's a little intimidating. But honestly, the Pride DX300, a lot of guys are afraid of them. We don't care. We will repair any 220 you got. Pride DX300s is our specialty. If you've got one that somebody hasn't been able to fix, we just sent one out last week that had been through I don't know how many hands. And by the time it was done, the man was keying 100 watts and PEP and 11 out of that 250B tube in that Pride 300 that wasn't supposed to be able to be fixed. And then we've got another 300 over here buried, I'm sure. Yeah, you see part of it back there. That one was totally butchered. And he's not going to be using the band switch anyway, so we took the band switch out, and that one's getting Frankenstein. Anything with a tetrode in it, we can take care of, period. From a 150A to a 400A tetrode. We can build it, we can repair it, we do whatever you need to do with it. So this one, however, is a triode. It wants about 200 watts of peak, about 100 watts of RMS, 125, and you'll get the full 2,000 watts out of it. However, you're running it at its limit when you do that. This is at least a 60-year-old amplifier that was built by guys like you and me. Now, somebody did a pretty nice job on this one, not the quality. I would have built one. I'm still looking for one that hasn't been built. It is my life's dream to build one of these from scratch, to take it out of the box and build it right, properly. And a lot of guys don't take the time. They spend the money when the kit was available. They spend the money and throw it together. This is not an amplifier that deserves to just be thrown together. One day I will find a kit that has not been put together, and I will put it together, and that is going to be the ultimate SB220. But for now, Hugh, I've gone over every inch of yours, buddy. Dual graphites, brand new high voltage section, automatic keying circuit, new parasitic chokes, new safety. Your tap on the bottom for 220 and 110 was hanging. We fixed that. All the switches work. All the meters work. All the selections on the meter work. This man got a nice amp. So these are nice amps, but they're expensive to maintain. So if you get one and you're getting it on the cheap, there's probably a reason. However, these amps, when they work right, sell for $1,500 to $2,000. Anybody that sells one for less than that, you're giving it away, and that's your fault. These amps are special. These amps are getting rare, and most of the ones I've seen are getting butchered. We've unbutchered this one. This man's got a straight-up 220 coming back to him, except for the band switch that we've added for him, and that was his request. So, or the automatic keying circuit. And like I said, he does have AM and sideband and a standby. It's like a regular amp. So no more keying pedals, no more having to have a Yaesu to key it. And if he's got something he's going to drive with this later on, he plugs the RCA into the back of this amp, plugs it into the back of the other amp. This one will key the other one automatically. That's the way we build our keying circuits. So when you guys want one of these to key automatically, we can do this. We can do this on any amplifier that you need a foot pedal for. We can make it automatic key. Guys will tell you they can't do it because that's going to blow up. It's going to blow up the keying circuit. They're full of dog poopy. Even if you don't bring it to me, bring it to somebody that knows how to work relays. You can put a keying circuit in any one of these high drive triode amps. You just got to do a little bit of work and know what you're doing. This gentleman has a year warranty on the amp, lifetime warranty on what I've worked on, which are the high voltage chokes and the keying circuit. Any of that ever goes bad, my lights are on. He's got a pulse. He brings it back. I fix it for free. Rest of the amp, I'm giving him a year on, except the tubes. We don't ever cover tubes. So I feel good enough about this amp to give him that warranty because it is in that good a shape after I have gone through it and made it in that good a shape. It came in half parts. It's going to leave a full-blown kick-ass amplifier. So there you guys go. This is how a 220 should be done. If you ain't doing it like this, at least do it where shit ain't arcing, because this amp is bad for arcing. You have got to have all your wires tied down and trained in a fashion where they are not going to have the opportunity to arc off of something else. Because in this small box with 2 kilowatts, it's going to happen if you're not careful. So there's my lecture on the SB220. I will get another one for myself one of these days. I had one, the filament transformer was bad. We ended up gutting it. But this one, we fixed this one for this guy and made it cool. So there you go. Quick overview, though. Look at those rails on the bottoms. If you're buying one, guys, take the cover off. Look at this bottom rail. Make sure this bottom rail ain't all bent to shit. And then inspect this high voltage section if you can. If it looks like it doesn't belong there, it doesn't. Because you can see this one is built exactly to spec, and everything flows and lands right where it's supposed to flow and land. So when you get in here and you see wires chopped and lots of electrical tape, no doesn't soldered down, grounds are wrapped around shit and not actually around a screw. Look, get away from that amp or buy it for super cheap, because it's going to need a lot of work. There are a few guys that do these really well. We're one of them. There's nobody that will warranty them like we do, though. So there you go. This is a Heathkit 220 with a 221 high voltage board. All the meters are perfect. Automatic key. Beautiful amplifier. We're proud to put this one out. Hugh, I hope you enjoy it. The rest of you guys, hope you dug this whole series on this amp. These are nice. If you get your hands on them, get your hands on them. Spend the money for a nice set of graphite tubes. Do not run regular 3-500Zs in these boxes. They work good, but they are nowhere near as stout as these guys right here. Nowhere near as stout. So that's just the other tip. So there you go. There's your lecture on the 220. We're going to put all these videos and pictures together, and you guys can check it out. Hope you like it. Old Mr. 409 in my parts file. We'll catch you guys later. 7-3s.